Hello everyone, Aaron here and welcome back to Leetcode. Today we are doing the reverse vowels of a string problem. Given a string S, reverse only all the vowels in the string and return it. The vowels are A, E, I, O, U, and they can appear in both lower and upper cases more than once. So, hello, we take the E, the O, and we flop them around. That's H-O-L-L-E. Leetcode, we have E-L, E, O, T, C, E, D, E. It's a bit of a spiral. Right. I think this one is probably best done in C. So I've switched the language over to C. And the reason I think that is because C strings are pretty terrible, but they are basically just arrays. They're an array of characters. So in this case, because we basically need to treat this as an array, I think that'll be fine. And also because it's a slightly easier problem, it's good to sometimes see how it works at the very lowest levels. I'm not quite going to do assembly. But C gives you a rough idea of what other languages are probably going to be doing under the hood anyway. Even if they don't present a string as an array of characters, that's usually what it is. Right, so I think what I want to do, well, return S, because then you can mutate S. And then what I want to do is int I equals 0, get j equals 0. And basically what I'm going to do is I'm going to have I and j start at the beginning and the end, and I'm going to sweep j back until it hits a vowel. I'm going to sweep I forward until it hits a vowel, and then I'm going to swap them. And I'm going to do that until I and j meet. So first we need to get to the end. So while sj does not equal the end of the string, j plus plus, j minus minus. So what this does is it says increment j while it's not at the end of the string, and then point j at the very last element, because this would have gone one step too far. It would have found the end, but we want to be pointing at the last character. We want to be pointing at the O, not the end terminator. So then, while I is less than j, while s, while not is vowel, we'll write a function is vowel, we want I to increment. While not is vowel s, j needs to come down. If I is less than j, we need to do this little swap business. Oops. Car temp is going to be si. Si is s. J, sj is temp, I steps forward, j steps back. This is a standard swap, and then I just do this little step forward and backwards, because if I didn't do the step forward and backwards, I and j are still looking at vowels, and then we would immediately swap them again, which is not what we want. So we need to step off the vowels in the correct direction. Now we're just left to do with this is vowel. So this is going to be bool is vowel char c. What I want to do is I want to switch on C, and if it's an A or a capital A, or an E, or a capital E, or an I, or a capital I, or an O, or a capital O, or a U, or a capital U, return true, default, return false. This is basically just, it doesn't look it, but it's a slightly compact way of doing a big old if-or thing. Are we counting Y? Yeah, no. A, E, I, O, U, upper or lower cases. There's probably a to lower somewhere in the C standard library, but I don't know what it is. So, in general, I think this works. So we initially set up I points at the beginning, J points at the end. While I is less than J, we're going to step I forward until it's a vowel. There's the E. J is going to step back till it's a vowel. That's the O. E and O get swapped. We're going to step I forward, J backwards. They're looking at an L. They haven't met yet, so I is going to step forward till it hits the O. J is going to step back. Well, it's going to hit the E. And J is going to step backward until it hits the what is now an O. But I and J are now in the wrong order. So we are going to exit our while loop and return the string. Let's give that a run. Typo check first, probably. Yeah, there we go. Oh, I need to put this above. Looks like I can't be bothered doing a declaration. There we go. Let's use all the example test cases. And let's do also something with some capitalization. Lovely, lovely. That all seems to be working. Let's submit it, see what happens. Runtime error. Ugh. Oh. Just to make sure I don't walk off the ends, I need to keep these I less than J checks. So the address sanitization error. Let's put that test case in here. So this is a string with no vowels, basically. Yeah, that's better. It shouldn't do anything. Safe. There was no way I was ever actually going to do it, but it was accessing addresses. Well, no. It was... Oh, yeah, no, this was unsafe because it was reading this. Never mind, ignore me. That was unsafe, so... I probably should have put those the other way around, actually. But anyway, this worked fine because this is a strictly less than, so it's going to trigger before anything else goes wrong. Perfect. Don't trust these runtimes. These are well within margins of error. It's fine. This is a nice little problem. You could do basically an equivalent solution in Python. You break your string into a list of characters. You then walk through those, swapping all of the vowels, and then join them back together again into a new string. That's perfectly fine. This just avoids that split and join. Other languages make this a little bit more difficult. If you were to do it in something like Haskell, you're in for a bit more pain, just because Haskell strings are not arrays, they are lists. And there is a difference. Go look up what a linked list is, and then you'll see why a string encoded with a linked list is probably not such the greatest idea. Anyway, that's it from me today. Do let me know down in the comments how you got on. Do remember to like, comment, and subscribe, all of that good stuff, and I will see you next time. Have a good weekend. Bye.